I am Pierluigi Arpenti, and in this brief presentation I will describe an integrated robotic depalletizing system for supermarkets' backrooms. Depalletizing is the process of unloading an object, such as a corrugated carton on a pallet, in a defined pattern. This procedure is common in logistics, where goods are typically delivered inside cases, which can be of different dimensions or weights. This task is hard and tiresome activity for human workers, since they have to manually remove a huge number of weighty cases. So, robotic depalletizing solutions have been deployed inside factories to substitute human workers and to increase productivity. In some logistics scenarios, like supermarkets, the products are heterogeneous and stored on pallets made of cases with different dimensions and textures called mixed pallets, which make the automatic depalletizing process an hard task. So we propose an integrated robotic system for mixed pallets, which has been recently presented in papers number 1, 2, and 3. This system can recognize and flexible depalletized cases from mixed pallets, avoiding invasive sensor or structural changes in the logistic process. And the proposed robotic system is composed of main 3 subsystems: an innovative gripping system to grasp cases from different sides, a perceptive system that identifies, recognizes, and localizes cases, and finally a strategy to schedule and orchestrate the palletizing sequence. The gripping system has been developed considering several requirements. For instance, it's able to grasp cases from top and side, to grasp cases placed over other cases, to automatically detect the case's orientation using the abandoned sensors, and so on. It is composed of 2 symmetric modules, each one equipped with a suction system and a fork that can be configured along the horizontal axis to adapt the gripper to cases with different dimensions or to complex shapes or fragile textures. The perceptive system is made of a case database which stores information about the cases in the pallet. For instance, barcode, the presence of textures, image of the textures, dimensions, and so on. The detection module, which detects candidates' cases from RGB data using feature detection, feature extraction algorithms, image segmentation algorithm, iterative algorithm to extract planar model from point cloud, and so on. And finally, we have a geometrical module which localizes cases in an inertial frame, identifies them by comparing their dimensions with those collected in the case database. The sequence in which cases are taken has to be decided online, depending on perceptual information fed by the RGBD camera. Priority is given to cases from the upper part to the base and from the sides to the center of the pallet to guarantee that the structural stability of the pallet is not compromised. Slight priority is given to frontal cases to support manipulability, since the pallet is placed in front of the robotic manipulator. The priority of the cases is also affected by requests that can be asynchronously provided by the system in response to specific logistic necessities. This system has been deployed in a real supermarket scenario considering a typical backdoor setting in which in approximately the 90% of trials the system was able to grasp the cases from at least one side. An accuracy of the 98% over a set of 180 recognition to be performed has been shown by the perceptive system. And finally, the average number of actions required to satisfy a request ranged between 11.40 and 7.13, depending on the trade-off between stability-oriented and request-oriented strategies. So, in conclusion, we have proposed an integrated robotic depalletizing system composed by an innovative gripper, a peculiar depalletizing strategy, and a novel perceptive system. And this system, which has been deployed in a real supermarket scenario, has shown satisfactory results in terms of grasping as well as recognition, localization, and satisfied the request. These are the references paper of the presentation. So thank you very much indeed for your kind attention.